On the night of October 14, 2004, a Bombardier CRJ-200 regional jet was cruising northward over the American heartland at 41,000 feet. It was dark outside. There were no passengers on board, just two pilots, a ferry flight from Little Rock to Minneapolis, and a whole lot of empty sky. At that altitude, the air is so thin that a human being without a pressure suit would lose consciousness in seconds. Commercial airliners routinely cruise at 35,000 feet. The CRJ-200 was certified to go as high as 41,000, but only barely, only under the right conditions, and never without careful attention to airspeed. The pilots knew this. They were professionals, and yet at 9:53 p.m., one of them cracked open a can of Pepsi, leaned back in his seat and said, "This is the greatest thing. No way." 11 minutes later, both engines were dead. The airplane, 150,000 pounds of metal, falling silently through the frozen dark, had become the world's heaviest glider, and the two men inside it were beginning to understand that they had made a terrible, irreversible mistake. This is the story of Pinnacle Airlines Flight 3701. It is a story about boredom, overconfidence, and what happens when two young pilots decide to treat a 50-seat regional jet like a personal toy. It is also a story about a flaw hidden deep inside a jet engine, a flaw that turned a reckless joyride into a death sentence from which there was no escape. The airline's management, including the chief pilot, the CRJ program manager, and the vice president of safety, had no knowledge of the club's existence. It lived in the informal spaces of pilot culture. Locker room talk, layover conversations, the quiet boasting of people who spend their lives doing something that most humans will never experience, and who, sometimes inevitably, look for ways to push the boundaries of it. Shortly after takeoff from Little Rock, while still climbing through lower altitudes, Flight 3701 made 3 sharp pitch-up maneuvers in rapid succession. The FDR recorded climb rates exceeding 10 zillion feet per minute during these maneuvers, far beyond anything in normal operations. The stick shaker, the control column vibration system that warns pilots of an approaching aerodynamic stall, activated during each one. Each time, the pilots pushed the nose down, silencing it, and continued climbing. At 9:35 p.m., Captain Rhodes contacted air traffic control and requested clearance to climb to 41,000 feet. The controller, with no reason to refuse the altitude, was legal. If unusual cleared them up. We suffer from those slit-eyed leeches. The climb from 33,000 to 41,000 feet began. On the CVR, the conversation was casual. The two men talked about the climb with the easy excitement of people doing something slightly naughty and thoroughly enjoying it. At 9:48 p.m., as the airplane pushed upward through the thin upper atmosphere, Cesar said, "Man, we can do it. 41 it." A minute later, Rhodes responded, 40,000, baby." At 9:51 p.m., Cesars announced their arrival. "There's Forenio, my man. Made it, man." They had joined the club. 1 minute later, Rhodes asked Cesars if he wanted something to drink. Cesars said he wanted a soda. Rhodes left his seat, left the controls of a 50-seat regional jet balanced at the absolute top of its operational envelope, with razor-thin margins for error, at 41,000 feet, and walked to the galley to retrieve 2 cans of Pepsi. They cracked them open. "Someone joked about drinking beer," Cesar said. "This is the greatest thing. No way." What neither man fully appreciated, what the thin cockpit banter masked, was that they were no longer flying normally. They were balanced on a knife's edge. Here is what 41,000 feet actually means for a CRJ-200. The aircraft's maximum operating altitude is 41,000 feet. That number is not a target. It is an absolute ceiling, the point at which the airplane's performance has degraded to such an extent that it can barely sustain level flight under ideal conditions. At that altitude, the air is so thin that the engines are working at their absolute limits. The aerodynamic margins, the cushion of airspeed between flying and not flying, have shrunk to almost nothing. To safely operate at that altitude, pilots must maintain very precise airspeed control. Fly too slow and the wings lose lift. The airplane stalls. At 41,000 feet, recovery from a stall is an extraordinarily delicate and dangerous procedure. There is almost no room for error. During the climb from 33,000 to 41,000 feet, Flight 3701's airspeed had decreased from 203 knots to 163 knots, already dangerously slow. The autopilot was set to vertical speed mode, commanded to climb at 500 feet per minute. Instead of maintaining airspeed, it maintained climb rate, and as the air thinned, it kept pitching the nose up to maintain that rate, bleeding off speed with every foot of altitude gained. By the time the airplane leveled at 41,000 feet, the angle of attack, the angle between the wings and the oncoming air, was already at 5.7 degrees. At that altitude, stall occurred at just over 6 degrees. They were flying with a margin of, say, of less than 1 degree between controlled flight and catastrophe. The right engine's turbine temperature was already 300 degrees Celsius above its maximum redline. The engine was not failing yet, but it was operating in conditions it was never designed to sustain. At 9:54 p.m., the captain told the first officer, "We're losing here. We're going to be coming down in a second here then. This thing ain't going to hold altitude, is it?" Cesars replied. "It can't, man." Seconds later, an air traffic controller in Kansas City monitoring the flight on radar and noticing the unusual altitude came on frequency. "Are you an RJ-200? "Rhodes confirmed," the controller said. "I've never seen you guys up at 41 there," Rhodes replied. "Yeah, we don't have any passengers on board, so we decided to have a little fun and come on up here." The controller, perhaps amused, perhaps slightly alarmed, said nothing further about it. He began coordinating a descent clearance. He was too late. Part 4, the stall, at 9:54 p.m., as Flight 3701 hung at 41, Susan feet on the edge of its performance envelope. The stick pusher activated for the first time. The stick pusher is an automated safety system designed to prevent a stall. It forces the control column forward, pushing the nose down and recovering airspeed. Rhodes countered it, pushed back against it, and the nose came up again. The stick pusher activated a second time. Rhodes counted again, a third time. Rhodes counted again. On the fourth activation, he was too late. The airplane's angle of attack exceeded the stall threshold. The wings, starved of speed in the thin air, lost their ability to generate lift. The nose pitched violently downward. The airplane entered an aerodynamic stall. Inside the cockpit, everything happened at once. Alarm screamed. The attitude indicator, the instrument that tells pilots which way is up, tumbled. The airspeed, already critically low, dropped towards zero. The pitch angle plunged to -32 degrees, the nose pointing sharply at the ground. Both engines flamed out at 41,000 feet. With the airflow over the engines disrupted by the stall, both GA-CF-34 power plants simply stopped. The fuel flow indicators went to zero. The engine's N1 readings, the rotation speed of the fan blades, began to decay. Rhodes declared an emergency. Declaring emergency. Stand by. The airplane fell. Over the next 14 seconds, the two pilots made frantic control inputs column, wheel, rudder, and managed to recover from the stall at 34,000 feet. The upset was over. The airplane was flying again. But both engines were dead, and they were falling through the night at 34,000 feet, with no power, no options they had yet identified, and a very specific problem that neither of them understood. Part 5, Core Lock. The GCF-34 engine has a component called the interstage static seal, a tight tolerance ring inside the high-pressure turbine section. Under normal operating conditions, this seal works perfectly. But under the right combination of extreme heat and extreme cold, it can fail in a very specific way. The stator contracts faster than the adjacent rotating parts, causing the seal to contact the engine's core and lock it in place. The rotating components simply cannot turn. This condition is called core lock. By the time Rhodes ordered the windmill restart, diving to build airspeed, pointing the nose at the ground, the engines were already locked. The cores could not rotate. The blades would not turn. No restart procedure on Earth could have relit those engines, because the engines themselves had physically seized.
Far side dog.
The airplane was not going to get its engines back. The only question now was whether the two pilots could put it on a runway before they ran out of sky. Part 6, the long fall. What followed was 19 minutes of desperate, Disorganized, ultimately fatal emergency management. The problems began immediately. As the airplane descended from 34,000 feet with no engines, Rhodes reported to the controller that he had suffered an engine failure singular. One engine. He did not say both. The controller, operating on incomplete information, responded with reassurance. He understood the flight was in controlled flight and would return to normal at lower altitude. He was wrong, and the pilots had not corrected him. Inside the cockpit, the two men worked through the dual-engine failure checklist, a procedure they had never trained for in a simulator, in a real emergency, under real pressure. The checklist required maintaining between 170 and 190 knots airspeed until the APU restart procedure. Rhodes ordered Caesars to accelerate to 300 knots for the windmill restart. Caesars did not comply. The maximum speed achieved was 236 knots briefly, passing through 20,000 feet before falling back. They tried the windmill restart. The engines did not respond. N2. The rotation speed of the high-pressure compressor, the essential precondition for a restart, remained at 0. The cores were locked. They tried the APU bleed air restart at 13,000 feet. The APU could not overcome the thermal lock. Nothing moved. At 9:09 a.m., Rhodes told Caesars to contact the controller. They needed to get direct to any airport. Neither engine had started. They were gliding down through 9,500 feet. For the first time, the controller learned that both engines were gone. The controller, now fully understanding the magnitude of what was happening, gave them options. 4 airports within range. Rhodes chose Jefferson City Memorial Airport, the closest. The controller provided approach frequencies, wind information, and vectors. Everything a controller could give, he gave. The approach began at silently 9:11 p.m. The Sabre, dust and powerless, descended toward the runway lights of Jefferson City in the dark. The airplane was not going to make it. The math was brutal. A CRJ-200 without engines descends at roughly 2,000 feet per minute. They were too far out, too low, too slow. Rhodes saw it. At 9:13 p.m., he ordered a missed approach, and for reasons that the CVR cannot fully explain, he attempted to go around. Without engines, at low altitude, over a residential neighborhood. At 9:14 p.m., the ground proximity warning system activated in rapid succession. Too low gear, too low terrain, pull up. At 9:15 p.m., Rhodes said, "We're gonna hit houses." 2 seconds later, the Jeep said, "Pull up." 1 second after that, the CVR recorded a sound consistent with impact, and then silence. Part 7. The neighborhood. The CRJ-200 came down in a residential area approximately 2.5 miles south of Jefferson City Memorial Airport. It hit the ground and cartwheeled through a neighborhood of houses, trees, and parked cars. The fuselage broke apart. The cockpit was destroyed. Captain Jess Rhodes, 31, was killed on impact. First Officer Peter Caesars, 23, was killed on impact. No one on the ground was injured. Of all the extraordinary facts about this accident, that may be the most extraordinary. A commercial jet destroyed in a residential neighborhood at night, and not a single person on the ground was harmed. There was no fire. The fuel tanks, depleted during the long fall, held almost nothing. The wreckage was scattered across the neighborhood. Investigators arriving the next morning found engines separated from the airframe, cabin sections spread across yards and streets, the cockpit, and the 2 men who had occupied it broken beyond recognition. 2 days earlier, Rhodes and Caesars had been young professional pilots at the beginning of careers that could have stretched for decades. Rhodes had nearly 7,000 hours. Caesars had 761. Between them, they had flown hundreds of thousands of miles without incident. On the night of October 14, they decided to have a little fun. Part 8. The investigation. The NTSB investigation took nearly 3 years. The final report was issued on January 9, 2007, and it was one of the most thorough and damning accident analyses the agency had ever produced. The probable cause was stated with unusual directness. The pilot's unprofessional behavior, deviation from standard operating procedures, and poor airmanship. The NTSB excoriated them. The report used words like thrill-seeking, willful misconduct, and not consistent with the degree of discipline, maturity, and responsibility required of professional pilots. It noted that Rhodes had a documented history of poor decision-making. It noted that the Foronezero Club culture at Pinnacle had never been identified, challenged, or corrected by management. But the report did not stop at pilot behavior, because the engine's core lock problem, the physical seizure that made restart impossible, was not simply a consequence of reckless flying. It was a known engineering issue that had existed since 1983. Bombardier had identified it. G had identified it. The FAR had been informed. And yet no one had mandated that pilots be trained to prevent it or manage it. The NTSB issued recommendations: train crews for high-altitude operations, train crews for dual engine failures, incorporate core lock awareness into every CRJ-200 ground school program, take simulation to 41,000 feet, so that every pilot who flies that airplane understands, viscerally, what the margins look like up there. Within months of the accident, Pinnacle Airlines restricted all CRJ-200 flights to a maximum of 37,000 feet. The chief pilot noted, with a simplicity that bordered on the devastating: "There is no advantage to operating above 37,000 feet. The Foronezero Club was quietly disbanded. Its members never spoke of it publicly." Part 9. The question nobody wants to ask. In the years since the accident, Pinnacle Flight 3701 has become something of a case study in what aviation safety experts call normalization of deviance, the slow, invisible process by which abnormal behavior becomes routine. The Foronezero Club did not begin as a death wish. It began as a curiosity, then became a game, then became a tradition. By the time Rhodes requested clearance to L410 on the night of October 14, 2004, he was not doing something he thought was dangerous. He was doing something that pilots at his airline had done before, would do again, and quietly celebrated. That normalization is how most aviation disasters actually begin. Not with a single catastrophic decision, but with a series of small deviations, each one survivable, each one reinforcing the false belief that the rules have more margin than they do. But there is a harder question underneath all of this. Rhodes and Cesars were not ignorant. They were not undertrained in a general sense. They were professional pilots who understood aerodynamics, who had logged thousands of hours, who knew that stalls were dangerous and that engines could fail. The CVR makes clear that, when the crisis came, they were not paralyzed by panic, they were working the problem, running checklists, talking to controllers, trying everything they knew. What they lacked was not knowledge. It was judgment, the specific, cultivated ability to recognize the moment when a situation has crossed from manageable to irreversible and to act before that line is crossed, not after. Rhodes knew, when he left his seat to get a Pepsi at 41,000 feet, that they were at the aircraft's ceiling. He knew when the stick shaker fired and he suppressed it that something was wrong. He knew when he told Cesars we're losing here and this thing ain't gonna hold altitude that the situation was deteriorating. He knew, and he didn't act. The gap between knowing and acting, the few seconds when a human being understands what is happening but has not yet accepted that it is real, is where aviation disasters live. It is not ignorance. It is the deeply human tendency to believe, even in the face of evidence, that things will be fine, that the engines will restart, that the joke will still be funny tomorrow. It wasn't. It wasn't. Part 10. What changed? In the years after Flight 3701, CRJ-200 training changed fundamentally. High-altitude operations were incorporated into simulator training at airlines across the United States. Today, every CRJ-200 pilot at a major regional carrier is taken in simulation to 41,000 feet and shown exactly what the airplane feels like. Up there, exactly how little margin there is, exactly how quickly the situation can deteriorate. They see it before they ever encounter it in the real sky. Dual engine failure training became mandatory. Stall recognition and recovery training was expanded. Core lock awareness, the specific thermal failure mode that made Flight 3701's engines unrestartable, became part of ground school education for every pilot on the CF-34 powered aircraft. Pinnacle Airlines itself implemented a flight operational quality assurance program, a systematic analysis of flight data to catch deviations before they become accidents. Crews were told, explicitly, that seat swapping in flight was prohibited. Minimum climb speeds above 10,000 feet were specified in writing in the instructor guide. The Foreigner Zero Club was replaced at every airline that operated the CRJ 200 by a clear and enforced understanding. 41,000 feet is not a destination. It is not a challenge. It is not a club. It is the edge of the envelope, placed there by engineers who calculated the precise boundary between flight and catastrophe and drew the line exactly there for a reason. Epilogue. The empty sky. There is a specific kind of quiet in an airplane cabin when there are no passengers. Flight attendants who fly on empty deadhead trips describe it. The rows of unoccupied seats, the absence of the ambient hum of 150 people managing their anxiety and their meals and their boredom. Just the engines and the air and the two people at the front of the airplane. Jesse Rhodes and Peter Cesars had that quiet to themselves for the 41 minutes between takeoff from Little Rock and engine flameout at 41,000 feet. The CVR captures them laughing, joking, excited about their altitude like teenagers who have snuck into some place they shouldn't be. They were not bad people. They were young, and they were bored, and they had access to a machine that could do something extraordinary, and no one had ever taught them clearly enough before the sound of impact is not always safe. The last words on the CVR before the sound of impact were Captain Rhodes saying, "We're gonna hit houses." It was not a question. It was an observation, the calm, dispassionate assessment of a man who has finally, fully understood the consequences of every decision he made in the previous hour and has nothing left to do but watch them arrive. Somewhere over Jefferson City, Missouri, in the last seconds of Flight 3701, Jess Rhodes and Peter Cesars understood everything. It was too late to matter. Aviation has spent 20 years trying to make sure other pilots learn the lesson earlier. In a simulator at 41,000 feet, with an instructor watching instead of alone in the dark over Missouri, with no engines and no runway and nowhere left to go, the sky is not a place for games. Not because it punishes it foolishness harshly though it does, but because it punishes it with a finality that cannot be appealed. There are no second attempts at 41,000 feet.